Hello guys, hello my students. This is another question 2. Still we are empirical formula. We are doing second example. So in this example, I will regard this is lesson 12. When you are checking from the YouTube, you can write lesson 12. So an oxide of silicon was found to contain an oxide of silicon was found to contain an oxide of silicon was found, this is silicon, was found to contain 47% by silicon. What is the empirical formula of the oxide? So the one, this time they give us, rather than giving us the mass, they give us percentage. There is no problem. So instead of using mass, you can use the percentage. So the procedure remains the same. You write first element, then the element here we have is silicon and oxygen. So because it's silicon oxide, so silicon Si, oxygen O. That's the element, the sample of the element. When you do that, the next, instead of writing mass, this time you write percentage mass. So the percentage mass of silicon is because they told you an oxide of silicon was found to contain 47%. Is 47, where oxygen is the remaining part, because the compound contains 100%. When you subtract 4600, what will you get? That's the remaining part of 47 will be oxygen. 100 minus 47, you will get 53. So 53% is oxygen. Where am I getting this 53? Somebody will ask you. Here we have 47% of the whole compound, which contains oxygen and silicon. So if silicon is 47%, then what will be oxygen? Let me say it again. The whole compound is 100% and the silicon is 47%. So what will be oxygen? Then 100 minus 47 to get the percentage of oxygen, which is 53. Then next we do it molar mass. Molar mass. The molar mass of silicon we have in the bracket 28. The molar mass of oxygen is 16. Okay, number of moles. The number of moles of silicon, you divide the percentage mass, which is 47, over 28. The mass, the number of moles of oxygen, the same way, you divide the percentage, which is 53, divided by 16. So when you divide this one and this one, what do you get? So when you divide 47 28, you'll get it 1.6785 and a number. So you round it. Instead of 5, you make it 6. Okay, here you divide 53 divided by 16. The same way you will get it 3.5. So then next is mole ratio. So in the mole ratio, you divide the smallest both sides to get the value of the mole ratio. So which one is smaller? 1.6786 and 3.5. This one starts 1 and this one starts 3. That means this one is less. So the smallest value, which is 1.6, you divide both sides. Divide by both sides 1.6786. 1.6786. So when you divide this one, you get 1 here, and when you divide this one, you will get it, and when you divide this one, you will get it 2. So here we have a ratio of 1 to 2. So 1 was from silicon. Silicon Si is 1. Where oxygen we have, it's producing 2. Oxygen 2. So therefore, the empirical formula of silicon oxide is this. You will eliminate 1, but you indicate the 2. Any value which is 1, you eliminate it, but the 2 is significant, you cannot eliminate it. So it is silicon 4 oxide. Silicon 4 oxide. That is how you do it, this question, the empirical formula. So that's how you do it. If you have mass, percentage mass, you use instead of mass. In the position of mass, you use that percentage mass. So if you have exact mass, you use the exact mass. So you should not worry about that. Okay, I hope you have understood it. Please subscribe and share. Thank you.